Page 507, question 10. Okay, so it says that y is equal to a times the log to the base 2 of x minus b. Okay, and it says it goes through the points 5, 2 and 7, 4. So what you're going to do is take the first point, everywhere you see an x put in a 5, everywhere you see a y put in a 2. So y is equal, 2 is equal to a times log to the base 2 of 5 minus b. Okay, you're going to play around with this and turn it back into an index. So 2 is equal to log to the base 2 of 5 minus b to the power of a. So that's base power answer 5 minus b all to the power of a. I'm just going to rearrange this so I get b equals, right? So that's 4 is equal to 5 minus b to the power of a. So then you get the eighth root of each side. Okay, so that's just 5 minus b here, and at this side it's 4 to the power of 1 over a. So in terms of b is equal to 5 minus 4 times 1 over a. Okay, that's that bit. Okay, hold that thought, hold that equation there for a while. Okay, back over here, everywhere I see an x, put in a 7, everywhere I see a y, put in a 4. So I get 4 is equal to a times log of 2 to the power, or log of 2 of 7 minus b, right? So that's 4 is equal to log to the base 2 of 7 minus b all to the power of a. Right, back to a power. So 2 to the power of 4 equals 7 minus b to the power of a. Right, so that's 16 equals 7 minus b to the power of a. So if that was to the power of 2, you get the square root of each side. If it was to the power of 3, you get the cubed root of each side. It's the power of a, you get the 8th root of each side. So that's 16 equals 7 minus b all to the power, square root of a, that's to the power of a. So the 8th root and the a will cancel each other out. So you get 7 minus b equals 16 to the power of 1 over a. Okay, so because this equation is in 4 to the power of 1 over a, I'm just going to change this to 4. Instead of 16, I'm going to write 4 squared to the power of 1 over a equals 7 minus b. Right, okay, and I'm going to rearrange that. So b is equal to 7 minus 4. Now I'm just going to swap those. 1 over a ought to be squared. Same thing. Right, so I have a b equals and a b equals, so I'm going to let them equal each other. So 5 minus 4 to the power of 1 over a equals 7 minus 4 to the power of 1 over a. 2b squared. Sorry. Okay, everything, I'm going to put everything on one side. So that's 4 to the power of 1 over a ought to be squared. So I brought that over and put it first. This is here already, minus 4 to the power of 1 over a. And then I have a plus 5 and a minus 7 when it comes over, which would be a minus 2. Okay, to solve this I need to do substitution. So I'm going to let y equal 4 to the power of 1 over a. Okay, so that would be y squared minus y minus 2 equals 0. Factorize y and y, 2 and 1, and a minus and a plus. So let each bracket equal 0, y equals 2 and y equals minus 1. Okay, so now I have to substitute back. Okay, so substituting back. Y is 4 to the power of 1 over a. So that equals 2. And 4 to the power of 1 over a equals minus 1. this is not valid, so that's not an answer. You can't get a negative number when you have an index. So here, 2 to the power of 2, all to the power of 1 over a equals 2 to the power of 1. That's 2 to the power of, I'm going to move it up, 2 to the power of 2 over a equals 2 to the power of 1. Knock off the 2's, so 2 over a equals 1. Cross multiply, a by 1 equals a, and 1 by 2 equals 2. So a is 2. And then go back and get a b. Right, okay, so I'll take the equation b equals 5 minus 4 to the power of 1 over a. So that's b is equal to 5 minus 4 to the power of 1 over 2. So 4 to the power of a half is the square root of 4, which is 2. So that's 5 minus 2. So that means b is equal to 3.